We'll take a look at the notion of a one-sided limit. I have over here, well, I have a function here, piecewise defined. So for x less than 2, it's the function x minus 1. When x is 2, the value is 2. And when x is bigger than 2, then you're using this here, 2x plus minus 2x plus 4, so that you can describe this piece going down there. So this is a function that it's one function, it just doesn't have one expression to get all the pieces expressed with the same way. So we put it in pieces. I want to look at what happens, what's going on near x equals 2. Okay, and so I have notation here. X is going to 2, and I put a little minus sign as an exponent for the 2. That's telling me that I'm going to 2, but going to 2 from the negative side, coming to 2 from a little bit less than 2. So I'm looking at what happened as I plug in values of x, getting closer and closer to 2, but always being less than 2. And in this case, it looks like the function values are getting up here to 1, and that's what it's saying, that the left-hand limit coming in from the left is equal to 1. Right? This notation here, x goes to 2 plus, there's an exponent there. That plus sign is actually in the exponent of the 2. It kind of gets lost in the notation here, but going to the 2 from the right side, from the positive side, so you're coming into 2 this way. Yes, you're headed left as you're going into 2, but you're on the right side. So coming into 2 from the right, the function value looks like it's getting up close to 0 here. And that's what the limit as x goes to 2 is. This is the function y, and that's my y value. What's the limit? Well, the left-hand limit is different from the right-hand limit, and so there is no limit. Right? If I were to change this function a little bit, I'm going to change this, this value to a 5 here, so it moves this piece up, and they actually match right there. And now I have a left-hand limit of 1 and a right-hand limit of 1. And this is reporting that actually the limit is 1 as well. Okay, left-hand limit coming in from x's underneath the value you're approaching. The right-hand limit is coming from above where the x value you're approaching. Okay. Notice here in all of this that the left-hand limit, the right-hand limit, the limit have nothing to do with what the function value is here. Right? At x equals 2, the function value is 2, yet the limit here seems to be 1. I can change this number all I want. Make this a negative 2. Right? The limit as x goes to 2 is still 1. In this case, the left-hand limit is 1, the right-hand limit is 1. If I change it back to my original one that I had there, right, left and right-hand limits are different, but still, from the left, the limit is 1. From the right, the limit is 0. Function value is negative 2. It doesn't have anything to do. This is an important point, that the value of the function at the point you're approaching, I'm approaching 2. So the value at 2 has nothing to do with what the limit is as you approach 2. Okay? This is something that you got to keep in mind. People get confused sometimes. There are certain functions, nice functions, where the limit is equal to the function value. I mean, I could set this up so that left and right hand limits are the same. Right? Left and right hand limits are the same. And if the function value is actually equal to that same thing, right? So if I had a function like this, where the function value and both limits are the same, both left and right hand limits are the same, then that's a kind of nice spot right there. We will talk about that as being continuous at that spot. But for now, I just want to emphasize the fact you've got left-hand limits, you've got right-hand limits, you've got limits. None of them have anything to do with what's happening at the point. The value at this point is irrelevant when it comes to calculating limits. Right? These numbers don't change. All right, thanks.